Hello, welcome to Wildcat Science with Mrs. Haugo. This is physical science and we are starting our physics unit today. So please find your new book, the red-orange one called Force, Motion, and Energy. And we are starting with Chapter 1 and Page 1. Or page 2, page 2. Okay, I would like you to follow along like normal, and with the exception that we're going to be doing some digital post-it notes instead of physical post-it notes in our books. So 1.1 is an introduction on forces. From early childhood on, you have pushed and pulled on various objects. As long as they were not too heavy, you could easily observe the effect of your push or pull. For example, pulling on the handle makes a wagon move. Also, kicking a ball at rest makes the ball move, since a kick is a very short push. Since a push and a pull both produce quite similar results, they have been given a common name, a force. Many times you are aware of a force because you produce a push or a pull with your own body. Okay, please take a moment and do your digital post-it note. So what if you push or pull on something and it does not move? Something must be pushing or pulling just as hard in the opposite direction. An equal force acting in the opposite direction balances your force. Not all forces require a contact or a touch to be exerted. As an example, you have observed a magnet pulling or pushing an object without touching it. If nothing is touching an object, how can you tell whether a force is acting on the object? The same rules apply as when there is contact. If the object was at rest and begins to move, a force was acting on it. If the object does not begin to move when a force is applied, there must be more than one force acting on the object and the forces balance each other. Tie a string to a pencil and hold it over your desk. When a pencil hangs from a string, the upward pull exerted by the string balances the downward pull so the pencil does not fall. Now cut the string. Okay, I have my pen on a string, and you should make a prediction about what will happen if I cut the string. So, the pencil, which was at rest, will move downward even though nothing was touching it. Apparently, a force was acting on the pencil that made it move downward. And we know what that force is, that makes things move downward even if you don't touch them. And if a pen is not moving upwards or downwards, then we know there has to be a force balancing gravity. And in this case, the force comes from the string. Gravity is pulling down, and the force of the string is pulling up. So in this chapter, you will learn how to measure a number of forces and how strong they are under certain conditions. Please take a minute and do your second digital post-it note. Okay, we finished reading that section. So please open up your binder to the notes section just like normal, and then table of contents. Please enter Chapter 1, 1.1, Introduction. And then this should be a new page. So start a new page and write your page number in there. Okay, so please go to that new page in your note section of your binder and write down Chapter 1, Forces. And then Chapter 1.1, Introduction. And as we know, a force is a push or a pull. And please write this down. When objects don't move, the forces on them are balanced. The forces are equal in strength and opposite in direction. So for example, if this pen is neither moving up nor down, we know that the forces on it are balanced and they are opposite in direction and equal in force. The force of gravity pulling down is equal and opposite to the force of the string pushing up. So there are touching forces like kicking a ball. you make an object move with a push from your foot, and there are not touching forces like magnetic attraction or gravity. Okay, those are all the notes for Chapter 1, Section 1. And next up, we're going to do our questions for that section. Okay, you will find your questions in a Google Doc on Classroom. Otherwise, you can open up your book and you'll be able to see it easier than this one. Does a table exert a force on a cup that rests on it, and explain? So some hints about that is if I have a table and a cup, and if we know that gravity is happening, we know that the cup with gravity wants to be pulled towards the ground. And if there is a table, if it's resting on a table, it isn't falling through the table. So is there a force pushing up to resist gravity? Okay, on the Google Doc, please use the race strategy and answer the question, does the table exert a force on a cup resting on it? And also explain why or why not. Okay, that is our science for today on forces, the introduction. Tomorrow we will be learning about proportionality and Hooke's law. See you then. Bye.